Right, so in this session we're going to look at identifying the nature of a formula by looking at its dimensions. By the nature of the formula, what I mean is, will that formula generate a value that is a length, an area, a volume, or whether it just is gibberish, it isn't a formula that's going to work. So to start with, we need to just go back to looking at what happens when we work with lengths. So if we have a length and we add a different length to it, what we get is a longer length, but it's still a length. If we had a length and we subtracted a length from it, we still end up with a length. So any formula where we're just adding or subtracting lengths is just going to give us a formula with length. Similarly, if we were to add maybe 3 lengths which are the same, then we'd end up with 3L1, which is still a length. So the 3, because multiplication is repeated addition, that 3 doesn't actually add anything to the fact that you end up with a length. So if in a formula you have a constant that's multiplied by a length, then you can pretty much ignore it, because all it does is produce an extra length. Now, if we multiply a pair of lengths, then we know from our sort of key stage 3 work that what that does is it produces an area. So if we've got a length times another length, we end up with a length squared, and we know that a length squared is an area. If we add areas, so if we've got an area 1 and an area 2, we can do that. That makes sense. It gives us a larger area, but it's still an area. Same if we subtract areas. So if we've got area 1 and we're taking out area 2, then it's still going to give us an area, which will have the unit's length squared. So if we end up working with the formula and we end up with length squared, then that's area. And if we have length squared, so if you think of your units for area, centimetres squared, metres squared, that's telling us this is a two-dimensional representation. Area is 2 dimensions. It covers space, flat space. Length is a 1-dimensional measure, and when we come to look at volume, we'll see that that is a 3-dimensional measure. What we can't do is, if we have a length times a length and then we want to add a length, so we've got a length squared plus a length, that is meaningless. That there's no formula that can generate that. You can only add or subtract lengths to each other, or areas to each other. So if you end up with something like length squared plus length, that's nonsense. It's not a formula. It's not possible. You can't physically add areas and lengths. So when we're looking at these questions, that's what we're testing. Are we going to end up with something that's all in terms of length, or all in terms of length squared, or, as we'll see now, length cubed? So those are lengths squareds, which are areas. So similarly, if we go back again into key stage 3, we know that if we've got a length times a length, that gives us an area. But if we've got another length and we're multiplying length by length by length, that gives us length cubed, which is volume. So when we're working with lengths, if we're multiplying 3 of them together, that gives us a cubic, 3 dimensions, which is volume. And similarly, we are able to add volumes. So volume 1 plus volume 2 would be another volume. And we can subtract them, but what we can't do is add a volume to an area. It's nonsense. Similarly, we can't add a volume to a length. So when we are working with these dimensions questions, if we end up with a combination of lengths cubed and lengths squared, or length squared and lengths, then we end up without a formula, or a formula that doesn't work. Right, so let's take a look at these questions. The first couple here, the sort of background to these is back in the late 1990s, early 2000s. These questions were on higher tier papers. Then in the mid 2000s until last year they went, and now they're back. So it's quite difficult to get hold of questions like these. So these were all off old past papers. So these first two are basically asking you to recognize the number of dimensions based on the language or the measure. So the first one, each of the following quantities has a particular number of dimensions. Give the number of dimensions for each quantity. The first one has been done for you. So the distance travelled in 2 laps of a circuit. Well, distance is length, which is one-dimensional. Volume of a cuboid. Remember, volume, the unit is centimetres cubed. If the units have got it cubed, it's a 3-dimensional shape. It gives us space. Area, so as soon as we see the word distance, volume, area is 2 dimensions, centimetres squared. Perimeter is a length, it's the distance all the way around a shape, so that's 1-dimensional. And again, area, 2 dimensions. So that's what we want to be thinking of all the time with these questions is it 1 dimension, length, 2 dimensions, area, 3 dimensions, volume. And perimeter and circumference are languages for distance. So, next question. Each of the following quantities has a particular number of dimensions. Give the number of dimensions of each quantity. Again, first one done for you. The key word there is capacity. Capacity is volume, 3 dimensions. Area, 2 dimensions. Volume, same as capacity, 3 dimensions. Distance is length, 1 dimension. Circumference is distance around the outside of a circle, so its length is 1 dimension. So those are relatively straightforward questions if they're asked in that format. The type that comes up more often is like the next one. So each of the following formulae, every letter stands for the measurement of a length. By considering the dimensions implied by the formula, write down for each case whether the formula could be a length, an area, a volume, or none. So whatever you decide the outcome is, you have to use those words, otherwise you don't get the mark. So you don't write perimeter for length, you have to write length. So the way that we do this is we replace, it's telling us that every letter stands for a measurement of length. So we can replace every letter by the letter L. And if you remember what I said earlier on, the number that's joined to the letters we can ignore. So we can take those out because they just increase the size of the length or the area or whatever it is. So what we have there is a length plus a length less a length. So if we write that down, and remember these aren't like algebra where, well, length L take away L is 0. That's just saying, and use this language in your mind as you're working. Length plus length makes a bigger length, and then we're going to take some length off it. Well, we're still going to end up with a length. So that's going to equal length, and I'm using the language that they're using there. So with this one, we can remove the 5. We can't knock the 2 out because that 2 is a power. It's telling us that that's a length squared. So we have a length times a length squared. Well, length times length squared is length cubed. Here you are thinking of it like algebra. So what we've got there is, if I go back to this example, that there is length times length, which gives us the area of a cross section, which we're timesing by another length. So length squared times length gives us length cubed, which is volume. So length times length squared is length cubed. Length cubed is volume. This one, AB, length times length, plus length cubed. Well, length times length is length squared, plus length cubed. That's adding, length squared is an area, which you're trying to add to a volume length cubed. You can't add things with different dimensions together. So an area plus a volume doesn't work, so it's none. So replace the A and the B with length times length, which is area, plus length cubed, which is volume. You're trying to add an area and a volume, can't do it. This one, we got a length plus, we can ignore the 2, length times length. So length plus length is just another length, times length, which is length squared, which is area. You can do this in your head if you can hear what I'm saying, and if you can say that length, so that's length plus length, length plus length is length, times a length is length squared, that's area. Length times length, length squared, area, plus length cubed volume, can't do. Length times length squared is length cubed, which is volume. So you don't have to do these bits. All they're interested in is your finished answer. But it might be helpful to put those stages in. And what you'll see now is these are very repetitive questions. So same thing, in each of the following formulae, every letter stands for a measurement of length. By considering the dimensions implied by the formula, you write down for each case where the formula could be length, area, volume, or none. So those are the language, the words I'm going to use. So the first one, we can ignore the numbers. So we've got a length plus another length, which is going to give us a longer length. This one, we can ignore the 6 and the 5. So we have length times length is length squared, plus length squared times length is length cubed. Well, that's an area plus a volume. This one, I got a length squared plus length times length, which is length squared. So that's an area plus an area, which is going to give me another area. So length squared plus length squared times outside the bracket length. So I got area, length squared plus length squared is going to give me another length squared, just a longer one, a larger area. So length squared times the length is going to be length cubed, which is volume. Length squared, length times length, length squared. Length squared plus length squared is a bigger length squared, times length, length cubed, volume. This one, ignore the numbers. I got length times length is length squared, plus length squared, minus another length squared. Area plus area, minus area, area. Here we go again. In each of the following formulae, every letter stands for a measurement of length. Considering the dimensions, write down for each case length, area, volume, or none. So length squared less length squared is another length squared. Remember, sorry, minus, that's just an area, take away an area, it doesn't equal 0, they're not the same. Times length. So area take away an area is another area, which is length squared, times length, length cubed, volume. We can ignore the 4. So we've got length plus length plus length is another length. Length times length squared plus length. So length squared is area plus a length. You can't add a length to an area, so that's none. And finally length times length plus length. So length plus length is another length, times a length is length squared, which is area. So you're adding two lengths to get another length, times a length, length times length, area. The final couple. So length squared times, ignore the 2, length take away length. Well, length take away length is another length, so doing length squared times length, which we can do, gives us length cubed, so that's a volume formula. This one, knock out the numbers, length plus length take away length gives us another length. And this last one, knock out the numbers, I have a length plus length times length, length squared, plus length. So we're trying to add lengths and areas together, which we can't do. So that doesn't give us a formula. And finally, length, take away length, gives us another length, times length squared. Length take away length is another length, times length squared is length cubed, which is volume. Knock out the numbers, length plus a length plus a length gives us a longer length. Knock out the numbers, length times length is length squared, minus length squared, plus length times length, length squared. So we're adding and subtracting areas, that's fine, it's going to give us an area. Knock out the numbers, area, length squared, plus area, length squared, minus a length. So we're adding areas and trying to subtract a length, which is nonsense. You can't do it. So that may feel a little bit weird, but hopefully you can see that actually that's not too hard to practice. So hopefully that will be something that you can get your head around. I mean, they're only usually worth 2 or 3 marks, but if it's something that you can get your head around, then that's an easy 2 or 3 marks.